Hello, my name is Cesar Saavedra and I'm a developer advocate here at GitLab. In this video, we're going to cover the creation, building, and deployment of a Quarkus native application to a Kubernetes cluster. We're going to start by asking a variety of questions to GitLab Duo Chat. The first one's going to be create a Hello World Quarkus application that can be natively compiled. GitLab Duo Chat returns a very thorough and complete answer to us with a lot of information about how to do this. GitLab Duo Chat is part of GitLab Duo, which is a suite of AI-powered features that can help you become more efficient and productive as you work in GitLab throughout the entire development lifecycle. The second question is going to be to create a dockerfile.native file for the sample application. Again, GitLab Duo Chat returns a very complete and thorough response. Third question is going to be create the pom.xml file for the sample application. And again, we get a very complete answer from GitLab Duo Chat. The next question is going to be create the content for the Quarkus test for the application above. Now we're asking all these questions of GitLab Duo Chat in preparation of the creation of all these files within our project. Now, since we don't know where these files are going to go into the directory structure, we actually ask Duo Chat to provide us with the entire directory structure of this project. And here we see the directory structure in a graphic way and the explanation of each of the files and their purpose and location. All right, now that we've got all the information that we need, we're going to start creating the directories and the files in our project. Our project is Quarkus-native. So we're going to go back to the answers of GitLab Duo Chat and look at the organization of the project and where the files are supposed to go. We're going to need a source main and a source test directory, as well as a target directory, and also the structure tells us where the pom.xml and the dockerfile.native should go. All right, so let's go ahead and start creating these files. The first file we're going to create is hello resource.java, which is, think of this as the main program or the main class. Now let's go back to GitLab Duo Chat again and copy the body of hello resource.java. Very good. So once we've pasted the first file into our project and into the correct directory, we're going to create a subdirectory called resources, and in there we're going to put applications.properties. And the reason that we're creating this file is because when we asked Duo Chat about the project structure, it required the existence of this file in the directory structure. All right, so let's go ahead now and create the hello resource test.java file. And let's go back to Chat and copy the content that Chat gave us for this class file. So let's space that. So now we have our main class, we have the application.properties file, and also we have our test class. We need to create one more file here called hello resource it.java. And we're heading back to the chat again, and we're going to copy the content. And this hello resource it class file is necessary for the native test class. As you can see, it's just extending the hello resource test class. All right, so the next file that we need to create is the pom.xml. Then we head back to the chat response and scrolled up to the location where it provided us with the content of the pom.xml, and we copy and paste the content. And when we're at it, we're going to go ahead and change the name of the artifact ID from Hello World Quarkus to something more appropriate for our project. So we're going to rename it Quarkus-native. While we're at it, let's go ahead and update the version of Java to 17 because we know that Quarkus supports 17 and higher as of the recording of this video. The next file we need to create is dockerfile.native, which is needed for the native compilation also of this project. And again, like before, we head back to Duo Chat and copy the body that was suggested to us for this Docker file. Very good. So now that we've pasted dockerfile.native, let's save all the files in our project. Actually, we forgot to do one more thing. We want to use auto deploy, and for that we need to set the service internal port. So we go ahead and ask Duo Chat how to do this. Now at this point we had the intention of using auto DevOps with this project, but later on we realized that we were not going to be able to use auto DevOps. So this file is really not needed, but we're just showing it to you because you will see it in the resulting project that is mentioned at the end of the blog post. At any rate, so we're going to copy and paste the content of auto deploy values for internal port and external port for the service. And then we're going to go ahead and save all the project files. So the next step is to test the project locally. So we're going to go ahead and open a terminal window and run maven clean package -p native. Everything seems to be running okay. And we are seeing an error here that says that we don't have these environment variables for graalvm, Java Home, and also to install it using gu install native-image. So we go back to Duo Chat and ask it how to fix this problem. And we provided the error message. And Duo Chat replies to us with some suggestions on how to solve this issue. And let's check out the answer. And it's first suggesting to go ahead and install graalvm on our local laptop. So let's copy that command and paste it in our terminal window. There you go. And it's going to be using the community edition of graalvm. And again, is the version that supports Java 17, because this is what we know Quarkus to support, Java 17 and above. Now notice that the specific version that is downloaded to the laptop is 22.3.1. And now we're going to check that it's being installed successfully. So we check that the directory exists under the Java Virtual Machines root directory. And we see that inside of it, there is another subdirectory with a specific version number for graalvm Community Edition for Java 17. And it happens to be 22.3.1. So the next command in the process that Duo Chat provided to us includes the creation and the exporting of an environment variable called Java Home. So we paste that and update it with the right version of the installed graalvm Community Edition. The next thing we're going to do is to export graalvm Home, and we're going to equate that to Java Home, which we already defined. Again, we're following the suggestions from Duo Chat. And Duo Chat is also suggesting that we update the path variable, which we will do. Now we are executing this xattr command that was not listed in the Duo Chat because we know that in the Mac platform we need to get the downloaded file out of quarantine, otherwise it will not execute. So the last command is running the gu command install native-image, which we do. We check the version of native image, and it is the one for Java 17 and is a community edition of graalvm 22.3.1. Just double check the Java version as well. And now we try again the maven command for clean package -p native. This time around the build seems to be going further. What's happening here is the actual executable is being created for that Java project. And the executable is really machine code that will run on the Mac. This is equivalent to compiling Java to machine code, similar to compiling a C++ or C program to an executable. So let's change directory to the target directory, which is where all the generated or created artifacts are going to be placed, and we double check that the executable is indeed there. It's named with the snapshot runner suffix at the end, and you can see the size of it. We're going to run the executable locally, and then we're going to go ahead and open a browser window and point it to the location of the application that is running locally. And as you can tell, it returns a string hello world, confirming that it is running locally and successfully. Just take a quick look at all the steps that Duo Chat had suggested to us, which we followed, with the exception of the command to get the GraalVM components out of quarantine on the Mac. So now that we've tested everything locally, let's commit everything to GitLab. This is going to be the initial commit. Now, when we committed this for the first time, we actually forgot to exclude the target directory, which we really don't need to commit. So the first time around, you see there's like 200 and change files that get committed. And this is something we had forgotten to do. So actually we went back and created a .gitignore file, and we included the directory target and its contents in there, so that the next time we do a git commit or any kind of git push, for example, the target directory and its contents would be ignored because they don't need to be committed or pushed to GitLab. Ideally, we should have done this before our first commit, but we're mentioning this so that you don't forget to do it. Very good. Back in our project, the next thing we're going to do is we're going to provide a prompt to GitLab Duo Chat, asking it to create a GitLab-CI YAML with 3 stages: build, containerize, and deploy, to basically natively compile our Java program into an executable and deploy it to a Kubernetes cluster. Now, in this prompt, we're specifying that we want to use Mandrill instead of GraalVM. Mandrill is an open source project that is a downstream release of GraalVM that focuses on native compilation for Quarkus. We're also specifying that we want the resulting answer to use our 3 existing variables: kube_ingress, kube_context, and kube_namespace. We'll go ahead and copy the response or the example of that pipeline, because we're going to paste it into a file we're going to create in our project, which is our pipeline file, our .gitlab-ci.yaml file. We're going to paste it there. So let's review the file, and we notice that the example file that was provided to us contains, for each job, it's making sure that it only runs on the main branch. At this point, we're not going to worry about that, so let's delete those rules from each of the jobs. Now, one thing we're fixing right now is the name of the dockerfile.native file. The example included the suffix -micro, so we're getting rid of that part of the name of the dockerfile.native. We want this pipeline to deploy to the production environment, but we didn't quite remember the syntax for including the production environment in the GitLab-CI YAML, so let's ask Chat about that. What is the syntax to specify an environment with its URL in a pipeline? And the response includes basically the explanation on how to do that and some examples. So this refreshes our memory and reminds us on how to do it. So let's copy those examples to our pipeline file. And we want to paste this towards the end of the file, which is for the job deploy. And let's update the name of the environment. We want it to be production. And let's go ahead and fix the URL. We should be using the kube_ingress base domain project variable that we already had defined with the hello path for the application. Also, let's get rid of the HTTPS, make it HTTP. Now, one last thing we need to do is we notice that there's a script called mvnw in line 23 in the pipeline, and we don't have that in our project at all. So let's ask Duo Chat, what is the content of this file for Quarkus? Now it tells us it cannot find any documentation. So let's be more precise with our prompt. So let's re-ask that question. And instead of asking just what the content of this file is, let's ask Duo Chat, how can I get the mvnw script for Quarkus? So in the reply from Duo Chat, gives us two options on how to get that file. So we're going to opt for the one that is just running the maven command wrapper :wrapper, which we have maven installed already. So let's just do that. We check the content of our Quarkus native project, and there is no mvnw script. So let's run the maven command to create that script. And then if we check the directory, you can see now there are two more scripts, mvnw and mvnw.cmd. Now that the scripts have been created, we can head back to the project directory and proceed with saving all these files and actually committing and pushing all these changes to the main branch. So let's go ahead and save everything and commit it to the main branch. Let's add a commit message first. We'll type in added GitLab CI YAML file to project. And we go ahead and commit. This commit is going to launch a pipeline in the project, which we see here with the 3 jobs and stages that we specified. Now the build job fails, so let's go into its log file, and we see that there's an unrecognized option -C passed to the image that we're trying to execute there, Docker image for Mandrel. We'll take advantage of GitLab Duo root cause analysis by clicking on the troubleshoot button, and that'll give us information as to how to solve the issue. And here we see that we need to double check the command we're trying to run and whether or not it's compatible with the Docker image we're using for Mandrel. Since that's an image we are using and we didn't put that image together, chances are that option is being passed to it. So in order to override that, we need to override its entry point. Now let's go ahead and ask Duo Chat how to do that. So we'll ask it how to override the entry point of an image using GitLab keywords. So Duo Chat is going to reply with a very thorough response about that. And now we remember how to do it. We need to add the entry point keyword in the pipeline file with basically a blank string. So let's go ahead and modify our image section here. We'll use the keyword name and then the keyword entry point and specify a blank string as the parameter that will be passed to the image when it's invoked. So let's save the changes and commit to the project again. We'll pass it a commit message overriding entry point or build image. Again, this commit is going to launch a new instance of the pipeline, which we can go and check. Now this is the new instance. The build job succeeds, but now the containerize job fails. Let's check the build job real quick. That has succeeded. We'll go into its log and we see that it completed successfully. However, we also see a strange warning message that says that dockerfile.native, suspecting it to be under source main Docker directory, cannot be found. So we go into the containerize log output file and we see that the docker build command is failing and again is unable to find the Docker file. So let's again take advantage of GitLab Duo root cause analysis. This is going to give us some information as to how to fix the issue. And the first option it's given us, it's this situation that we are seeing. So we need to go back to the project and look at the pipeline file and make sure that the location of the dockerfile.native native file is correct. Now the location is in the root directory of the project, so we need to basically get rid of all the preceding path for dockerfile.native and just leave it like that so that it can find it at the root directory of the project. So let's fix that in build and also containerize. We need to fix it in build because build is the one that saves that file as an artifact that passes it on to the next job, which is containerize, which is where the job is failing. Let's commit the changes. We'll quickly provide a commit message about fixing the location of dockerfile.native file in the pipeline job. And again, this commit's going to launch a new instance of the pipeline, which we can go and check. There, that's a new pipeline that is being run now, and the build job should succeed. Containerize succeeded as well, and the deploy job also succeeded. Let's go into the containerize job log output, and it looks fine. It looks like the executable was successfully created there. And also the deploy log output shows the actual URL that we need to click on to access the application. So let's click on that. Remember, this string had the HTTPS enabled, so we have to get past that. And we see that the application is running because we see the hello world string returning on the web page. Now, we also had an environments section in the pipeline file, which sets up the production environment, which is right here. And do you see the open button? That is linked to the URL we specified in the pipeline. And when we clicked on that, we again see the hello world string. So in this video, we were able to create, build, and deploy a simple Quarkus native application to a Kubernetes cluster by leveraging the power of GitLab Duo, which helped us be more productive and efficient at every step of the way. Thank you for watching, and until next time.